In this video, we'll be looking at identities and equations with no solution. We're going to start with a story that illustrates what an identity is. So, as part of her sports training, Sophie had to walk 5 miles a day. On Monday and Tuesday, it took 80 minutes to complete the walk. On Wednesday, it took 1 hour and 20 minutes. How do you account for that? Well, if we assume that Sophie walks at the same amount each day, then how can you account for the fact that it took 80 minutes on Monday and Tuesday and 1 hour and 20 minutes on Wednesday? Think about that for a moment. Stop the video. When you think you have an answer, restart it. Well, you may have figured out that 80 minutes is really the same thing as 1 hour and 20 minutes. There are two ways of expressing the same thing. And that's exactly what an identity is. It's an equation that compares two expressions that express the same thing. Here's an example. The perimeter of a rectangle, and I can draw a crude rectangle like this, that has a length and a width. So, maybe that's not right. Maybe we should have it the other way. So we'll call this the length and this the width. Not that it matters. But anyway, so we have this rectangle, and we can compute the perimeter by adding the width and length first and then multiplying by 2. Or we could take 2 times the length and add that to 2 times the width. Either way, we get the same thing. So we could write an equation, an identity, that shows that 2 times the length plus 2 times the width is the same thing as 2 times the length plus the width. Now, if you have two expressions that are so different that you really can't tell whether it's an identity, one way of telling is by just making a table with different values. So we'll take a look. So let's say in this identity we used a length of 3 and a width of 4. Okay? So if we compute it the first way by adding the length and width together and then multiplying by 2, so 2 times 3 plus 4, we get 14. And if we multiply the length by 2 first, then multiply the width by 2, and then add them together, we still get 6 plus 8 is 14. And we might want to verify this with another. So we might take a look at this. Take a length of 7 and a width of 15. And 2 times 7 plus 15 is 2 times 22. That equals 44. And 2 times 7 plus 2 times 15 is 14 plus 30, and that is 44. So we can see that for any combination, the two numbers are the same, so this is an identity. And here's the last one. For 10 and 1, we can see that those are the same as well. Now, I'd like you first, before I show you how to solve these, to try solving these using the techniques that you've already learned, and I want you to see what happens. Copy the problems into your journal, do the work in your journal, and restart the video once you've completed solving the problems. Okay, if you're done now, you might have noticed that there's something unusual about these problems. So let's take a look at the first one. The first step that you might have done is to expand the parentheses and make this 4x plus 12 minus 6 equals 3x plus 6 plus x. Then you can collect terms. You get 4 plus 12 minus 6. 12 minus 6 is 6, so that's 4x plus 6 equals 4x plus 6. Well, that's an identity. These two things are exactly the same. So even though these two didn't look the same, we know that they are the same. Let's now take a look at this next one. Negative 2 times x plus 7 equals 5x minus 14 minus 7x. They don't really look similar, but let's see if they are. So the first solving step might have been to expand the parentheses into negative 2x minus 14 equals 5x minus 7x minus 14. We'll just switch these two terms around. Next, we'll collect terms over here on the right. So 5x minus 7x is negative 2x minus 14. And we have these two sides as equal. Now, maybe you were asleep at the wheel and you didn't notice that these two were the same. So maybe you took another step. So let's say that you added 2x to each side. And if you did that, you would come up with negative 14 equals negative 14. This statement here is always true. Always true. So because it's always true, this was an identity. Okay? Now I'd like you to try these two identities, and I'd like you to work them down until the point where you can determine conclusively whether or not they are identities. Stop the video, copy the problems into your journal, do the work, and then turn the video back on when you're done. Okay, let's take a look at the first problem. The first step that we might take would be to expand the parentheses. So this would be 14z minus 28 minus 2 equals 10z minus 30 plus 4z. Next, we'll collect like terms. So negative 28 minus 2 is negative 30. So this is 14z minus 30. And this is 10z plus 4z. That's 14z minus 30 as well. So there's your solution. And now this is an identity. Let's check this one on the right. First, we'll expand the parentheses. 8r minus 2r minus 2 equals 6r minus 2. And then we can add like terms. 8r minus 2r is 6r, so this is 6r minus 2 equals 6r minus 2. And that also is an identity. Okay, so this is a real head scratcher. Bob and Carol went to the store. They each bought a binder and some pens, but they forgot the price of the pens. When they left the store, they were talking about how much they spent. And Bob said, well, I bought 3 red pens, 4 black pens, and a notebook for $2.50. And you bought 7 black pens and a $3 notebook. And we both spent the same amount of money. Let's see if we can figure out how much the pens cost. Well, okay. So they wrote an equation. They said, well, see, Bob bought 3 pens, 3 red pens and 4 black pens, and the pens cost the same amount, plus $2.50. And Carol bought 7 black pens and 3 and a $3 notebook, and they both spent the same amount of money. So we can express that as an equation that they both spent the same amount of money. And now let's go ahead and solve. So, well, we have 7p plus 250 equals 7p plus 3. That looks a little odd. And let's subtract 7p from each side. And then we get 250 equals $3. Well, that doesn't look right. What's the problem? The problem is that there was a mistake someplace. And we don't know where the mistake is, but the fact is that this equation, 7p plus 250 equals 7p plus 3, has no solution. So there are problems that you'll come across in math that we can write equations for, but in the end they do have no solutions. I'd like you to try solving these two equations, and I want you to see what happens with problems that have no solution. I'd like you to copy the problems into your journal, do them there first to the best of your ability, and then restart the video when you're ready to see the solutions. Okay, so let's take a look at the first one. With the first one, first thing we'll do is expand the parentheses, and this will become 4x plus 12 minus 5 equals 3x plus 6 plus x. Next, 4x plus 12 minus 5 is 4x plus 7, and that equals 4x plus 6. Well, that can't be. If we do one more step, subtracting 4x from each side, we'll notice that we get a statement 7 equals 6. This statement is never true. So there is no solution. And when you have a problem where this happens, that's what you write, no solution. Now let's take a look at the second one. Here, once again, we'll expand the parentheses first, changing this into 2x minus 14, that's negative 2 times x, negative 2 times 7, 2x minus 14, equals 5x minus 7x minus 11. We'll add like terms on the right side. So we get negative 2x minus 14 equals negative 2x, that's 5x minus 7x, minus 11. And then maybe we'll add 2x to each side, and we'll get this 14 minus 11. Negative 14 equals negative 11. That's definitely not true, so here we write no solution. I'd like you to try solving this equation, and I'd like you to do that in your journal, and I want to see if you can decide whether this has a solution or it does not. Okay, so let's go through the solving steps and see what they are. So first, we'll do what we would normally do. So we will expand the parentheses. We get 4x plus 28 equals 3x plus 28. Now that looks like it has no solution. So let's subtract 28 from each side, and we'll get 4x equals 3x. That still looks like it has no solution, but maybe you want to try something. Maybe you want to try dividing each side by 4 to get rid of the 4 on the left. And then what you get is x equals 3/4 x, which still looks like it has no solution. Well, actually, this problem does have a solution. So if you have something like 4x equals 3x, you could subtract 3x from each side. And if you do that, we find that we get x equals 0. And if you test 0 as a solution to the equation by substituting 0 for x, you'll find that this is indeed a solution.